I have a couple problems here. This is the one where you have to use the inverse norm with the standard normal distribution, and you have to use the z-score. So I've had a little bit of a mess up here, but again, if you want to practice these, I suggest you pause the video, work this, then I'll work this one, pause it again and work this one, and so on. All right, so first of all, on this one, it says right here that the weight of a legal keeper size yellow basket has to be at least 10 inches long for you to keep it. Once it makes it into that realm, the weight is approximately normally distributed with 1.2 for the standard deviation. It says the largest 17% of these weigh at least 5.3 pounds. All right, so first of all, we need to do inverse norm. Okay, and we just need that percentage, and we're going to get a z-score using that percentage right there. So now this one also says the largest, but remember, when we do area, it has to be the smallest. So I'm going to actually use 0.83, and then mu is 0 and sigma is 1. Now in the calculator, I go second vars number 3, and then I just type in what I just said right there. And again, it's 83% or less if it's 17% above. Hit enter a couple times, and I get 0.954. I'll just leave it as that. That's the z-score, not the percentage. Okay, we already put in the percent. That's the z-score. So then I use the z-score formula, and I'm going to go ahead and write it in the formula. You wouldn't need to do this, but it's notes or practice, so we might as well see it. So that's the z-score formula, and it said the standard deviation was 1.2. And then it said the largest 17% was 5.3. So 5.3 was the observed value, and we're trying to find the mean weight. And then that z-score, anytime anything is at the top 17% or the bottom 83%, that's going to be their z-score. Okay, and then I just solved this algebraically. Now, I've also, here's this little trick here. So after I type in inverse norm, I get this huge decimal. I can actually use that entire decimal instead of the rounded one. It really isn't going to be a big deal. We will accept different rounded answers, but it is nice it's already in there. So I'm just going to hit times 1.2, enter, and then I subtract the 5.3. And then it's negative x bar equals negative 4.155. So x bar equals 4.155 pounds. Mess that up on my key for the review. All right, so again, you should go ahead and try this next one now. You should pause it and work this one. I know you don't have a worksheet, but you can pause it and look at the words. The number of jalapenos that are harvested from a healthy plant that receives proper water is approximately normal with the mean of 35 peppers. The lowest 21%, so I don't have to do that hundreds partner thing like I did up here, yield 27 peppers. What's the standard deviation? So this, I'm going to do inverse norm to get my z-score. So area is 0.21, mu 0, sigma 1. Okay, I don't know what that was all about, but second vars, inverse norm. This time, I already forgot, 0.21, 0 and 1. And I get negative 0.8064. And again, that's my z, so negative 0.8064 equals, and remember, we're trying to find the standard deviation, so sigma is going to be the unknown, and it was 27 plants minus the average of 35, and the 27 should be smaller than 35 because we got this negative right here. All right, so 27 minus 35, just type that in. Maybe you could have done that. Just wrote that in straight instead of writing the subtraction. And remember, if a thing is equal to a fraction, that thing and the denominator are interchangeable. So I want negative 8 divided by, I already have that, divided by negative 0.8064. And then I get 9.92 peppers. All right, there's a video for those two questions. I'm also going to make a video for a z-score problem and some normal CDF other